The first light was wrong. It came from the south, a blue-white glare that brightened the northern sky of a Siberian summer morning. Too soon, too wrong. A hunter named Semyon was on the riverbank near the settlement of Varnavara, roughly 60 kilometers from the epicenter. He saw the light swell, felt the heat, and a second later he was thrown backward into the side of his hut. The explosion came later, a series of thunderous bangs, then a wall of wind that smashed windows and tore doors from hinges. It was June 30th, 1908, around 7:17 a.m. Semyon's morning was a routine of survival. The Twyga forest, along the stony Tunguska River, was a world apart, a sea of pine and larch where the Avenki people hunted reindeer and Russian fur traders maintained scattered outposts. Life was measured in the catch, the firewood, the short summer thaw. It began with the sun's weak glow on the horizon and the first stirrings of camp dogs. There was tea to boil, gear to check. The forest was not silent. It was a thick world of buzzing insects, creaking branches, the distant cry of a bird. But it was a contained world, a world of known horizons. All of that was about to end in a fraction of a second. The fireball that tore across that sky was traveling at more than 50,000 kilometers an hour. It was a cosmic visitor, likely a chunk of rock and iron about 60 meters across, the size of a large office building that had spent millions of years orbiting in the main asteroid belt between Mars and Jupiter. It entered Earth's atmosphere at a shallow angle, compressing the air in front of it into an incandescent plasma. That's what Semyon saw. Not a meteor in the streak of light sense, but a second sun plunging to Earth. For a few seconds, it outshone the real one. The radiant heat it threw off was intense enough to singe clothing, to ignite fires miles away. Then, at an altitude of about 6 to 10 kilometers, high above the cruising altitude of a commercial jetliner, the stresses became too great. The object didn't so much explode as violently disintegrate, coming apart in a catastrophic release of kinetic energy. It happened instantly. The result was an airburst. Picture the largest man-made explosion in history at that time. Multiply it by 1,000. The energy released has been estimated between 10 and 30 megatons of TNT. To put that in perspective, the atomic bomb dropped on Hiroshima was about 15 kilotons. This was 500 to 1,000 times more powerful. But because it happened high in the sky, there was no fireball on the ground, no classic mushroom cloud. Instead, the energy manifested as two terrifying phenomena: a searing pulse of thermal radiation and a supersonic shockwave. The thermal pulse washed over the forest first. In the central zone, the heat was so intense it vaporized the moisture in tree trunks instantly, causing them to burst. It ignited the resin in the pines, starting spot fires. It scorched the reindeer moss and lichen to a crisp. Animals caught in the open were flash burned. This all happened in the blink of an eye, before the sound even arrived. Then came the sound, a deafening series of booms that echoed for hundreds of kilometers, and the shockwave. This was a wall of compressed air moving outward at the speed of sound, then faster. It hit the ground like the hammer of a god. 80 million trees, across an area roughly the size of a major city like London or New York, were knocked flat. They didn't just fall over. They were laid out in a vast, precise radial pattern, like spokes from a wheel, all pointing away from the point directly below the blast. This was the butterfly pattern later scientists would map, a perfect fingerprint of an overhead explosion. At the very center of this devastation, a strange sight awaited. A small cluster of trees remained standing. They were stripped bare of every branch and all their bark, bleached white and shattered at the top, standing like charred telephone poles. These were the telegraph pole trees. They survived because the force of the blast at the exact epicenter was directed straight down. It sheared off the branches but didn't have the lateral push to topple the trunks. It was a clue that would later prove crucial. But Semyon and the other scattered inhabitants of the region didn't know any of this. Their day in the life had been violently interrupted. For them, the event was a terrifying mystery. The shockwave knocked people off their feet hundreds of kilometers away. In the town of Kansk, over 600 kilometers distant, a train engineer felt his train shake violently and stopped, fearing a derailment. The sound of the explosion was heard over 1,000 kilometers away. Seismographs across Europe and Asia recorded ground tremors equivalent to a magnitude 5 earthquake. More eerily, for nights afterward, skies across Europe and Russia glowed with an unearthly, silvery light. People in London could read newspapers outdoors at midnight. This was caused by vast amounts of fine dust and ice, likely from the vaporized object injected high into the stratosphere, catching the sun's rays long after sunset. In the immediate aftermath, the day's routine was shattered into survival and confusion. Fires burned in the downed timber. Hunters found entire herds of reindeer killed, their bodies charred. The air smelled of ozone and burnt resin. Rumors flew faster than any news could travel in that remote land. Some thought it was the end of the world. Others spoke of a wrathful god. A few, hearing of the bright light and explosion, wondered if it was some secret, colossal weapon. The Tsarist government, embroiled in pre-revolutionary turmoil, showed little interest. To the wider world, the event was a series of odd scientific readings and strange sky glows. The epicenter was so remote, so inaccessible, that no official investigation was launched. The Tyga simply swallowed the mystery. For nearly 2 decades, the Tunguska event remained a local legend and a global scientific curiosity. It wasn't until 1927, under the new Soviet state, that the first scientific expedition reached the site. It was led by a determined mineralogist named Leonid Kulik. He was driven by a simple belief: such a huge explosion must have left a giant crater, and with it, a treasure trove of meteoric iron. He expected to find a smoking gun from space. What he found bewildered him. After an arduous journey by rail, riverboat, and finally on foot through swampy, trackless forest, his team reached the zone. They didn't find a crater. They found a landscape of unparalleled, directed destruction stretching to the horizon. Kulik climbed a ridge and looked out over a sea of fallen trees, all aligned away from him. At the center, the ghostly stand of limbless, burned trunks. He took photographs, made maps, and searched desperately for fragments. He found small pits and bogs which he initially thought might be craterlets, but they were just permafrost melt pits. He found no significant meteorite pieces. The lack of a crater and the radial treefall pattern were the first major clues pointing away from a ground impact. This was something else, an airburst. Kulik would lead 3 more expeditions, obsessed with solving the puzzle. He never found his giant iron meteorite. His work, interrupted by World War II, during which he was captured and died in a German prison camp, laid the essential groundwork. He had documented the phenomenon. The mystery deepened into the 20th century, spawning wild theories in the absence of a definitive answer. Was it an alien spacecraft exploding? A chunk of antimatter annihilating with ordinary matter? A tiny black hole passing through the Earth? These ideas flourished in the vacuum of hard evidence. The real answers began to cohere as science developed tools to understand what it was seeing. The key was recognizing that our atmosphere is not empty space, it's a fluid, and objects moving through it at hypersonic speeds experience immense pressure and heating. Studies of nuclear test airbursts in the 1940s and 50s provided a chillingly perfect analog. The pattern of destruction, the telegraph pole trees, the lack of a crater, all matched an energetic, high-altitude explosion. Modern computer modeling confirmed it. An object tens of meters across, entering at a shallow angle, would be torn apart by aerodynamic pressure before it could hit the ground. Its entire immense kinetic energy would be deposited in the air. Later evidence solidified the asteroid theory. In 2013, analysis of microscopic particles embedded in peat from the area and in tree resin from 1908 found elevated levels of elements like iridium and other minerals in ratios that screamed asteroid, not comet. Orbital modeling published in 2018 suggested an 83% probability the object came from the main asteroid belt. The scientific consensus crystallized. Tunguska was caused by the atmospheric explosion of a rocky asteroid roughly 60 meters in diameter. A fascinating and still disputed alternative hypothesis emerged more recently, the grazing impact theory. This suggests the object was larger, perhaps a 200-meter iron asteroid that didn't explode outright. Instead, it entered at an extremely shallow angle, skipped through the upper atmosphere like a stone on a pond for over 3,000 kilometers, generating a devastating shockwave from its passage and then arced back out into space. This could also explain the lack of a crater and the immense damage. It's a compelling idea, but it remains a minority view. Most scientists still point to the clean, elegant explanation of a total airburst disintegration. The legacy of that Siberian morning is more than a solved mystery. It was a wake-up call, a cosmic reminder delivered to an empty corner of the world. If that object had arrived just 4 hours and 47 minutes later, Earth's rotation would have placed the city of St. Petersburg directly in its path. The entire city would have been erased. Events on the scale of Tunguska are estimated to occur once every few hundred to 1,000 years. We got a free pass in 1908. A more recent, smaller reminder came in 2013 when a 20-meter asteroid exploded over Chelyabinsk, Russia, injuring over 1,000 people with its shockwave. It was a Tunguska-scale event in miniature. So the day in the life that ended for Semyon, the hunter, and the Tyga forest that morning became a foundational data point for planetary defense. It taught us that the threat from space isn't just about dinosaurs and giant craters. Sometimes the sky itself can become a weapon. The visitor left no crater, no monument, just a vast, silent scar in the forest, and a question that took a century to fully answer.